All right, in this video we're going to look at how to solve equations by completing the square. Sometimes equations can't be solved by factoring, and so we have to come up with other methods. So one of them is the method called completing the square. Let's take a look at these problems right here as we factor them, because these types of problems will just be a part of today's lesson. So if we were to factor all of these, we would find that each of them have a unique and very similar story. They are what we call perfect square trinomials. And so I want to take a look at the DNA of these problems. This, of course, is x plus 3x plus 3. Notice, and this is real important, that there is a 1 to 2 ratio between these two numbers here. So if this number is 6, this number is 3. And the other relationship is if I square 3, I get 9. Okay, so again, half of negative 6 is negative 3. Negative 3 squared is 9. Half of 2 is 1, and 1 squared is 1. Half of negative 8 is negative 4, and negative 4 squared is 16. Half of 12 is 6, and 6 squared is 36. Half of negative 10 is negative 5, and negative 5 squared is 25. So this pattern is predominant in this method of solving by completing the square. So all of these are called perfect square trinomials because we have identical twins here. We have x plus 3, x plus 3. We have x plus 6, x plus 6. We have x minus 5, x minus 5. And so these are called perfect square trinomials. All right, and we've already picked out these patterns. Let's look at the process of completing the square. So if I were going to make this a perfect square trinomial, what I would have to do is I would have to make the polynomial factorable into a binomial squared. So I'm looking for the number that would fit into this box. And the way that I do that is I'm going to split b. Remember your ABCs of quadratic equations. This is your b value. If you split it in half and put it here, this is how it would be factored. So the question is, what do I put here? And the answer is 7 squared, or 49. And again, now if you look at this, how do you factor this? It's going to be factors of 49 that equal 14 are x plus 7 and x plus 7. All right, so this pattern this thread runs straight through all of these questions. So again, this kind of shows you that it's x plus 7, gives you the following trinomial. All right, so if we were again to fill in this blank, this over here is equal to half of this. So we'd split that in half and put a 4 there. But what we would put in the box is this number squared, or 16. Okay, let's look at another one. Split b in half, and you get 12. Square 12, and you get 144. Split b in half, and you get 5 halves. Square 5 halves, and you get 25 fourths. Split negative 16 in half, and you get negative 8. Square negative 8, and you get positive 64. split -7 1/2, and you get -7/2. Square -7/2, and you get positive 49/4. Split -1 1/2, and you get 1/2. Square 1/2, and you get 1/4. All right, so the format here is, first of all, that the leading coefficient, or the value of A, is always 1. The value of this number here is the split of B squared. All right, so let's keep going here. So when you're solving quadratic equations by completing the square, we're going to go through a few steps here on how to do that. All right, completing the squares. Sometimes some equations cannot be factored. For example, if we look at this, there's no factors of 2 that subtract to equal 6, which means that the x-intercepts are just not rational. They're going to be irrational zeros. As we look at this graph, this is this graph plotted on an x-axis, and we're looking for these answers right here. You can see that these are non-readable points. We can't tell what that is. So what we can do is use this method of completing the square to find them. All right, so looking at this problem, one of the conditions is you have to have a leading coefficient that's 1. So we must divide by A if A is not equal to 1. And we're going to move this constant over to the right-hand side. Okay, so it doesn't matter what you do first. You're going to divide each piece by 2 to get that leading coefficient equal to 1. And then you're going to move the constant over to the right-hand side. So we're going to add 11 to both sides. When you finish, your equation should look like this. X squared plus bx, b is, again, generic, so in this case it's 6x, equals a constant, or the opposite of the constant. So the opposite of -11 is +11. And then what we're going to do is we're going to do what's called completing the square. So we're going to add the number that completes the square. Okay, so remember, if we are going to write this as a perfect square trinomial, we would take half of b and put it here. The number that goes in this box is the square of 3, or 9. We will add 9 to both sides. And then we will solve for x. Now we did this in class the other day. To undo a square, you take its square root. The square root undoes the square, and we're left with plus and minus 20. Now 20 does have a perfect square embedded in it. The number 4 is embedded in 20. So we'll convert that square root of 4 to its equivalent of 2. Now we're solving for x, so we're going to subtract 3 from both sides. And this is our answer. It actually splits into 2 separate answers, -3 plus 2 root 5 and -3 minus 2 root 5. And if you were to put that into your calculator, these were the values you would get. And that's how you solve by completing the square. All right, so again, the steps are move the 7 to the right-hand side by subtracting it. We're going to now complete the square. Okay, the way we do that, best thing to do is split the b and then square it. So you're going to split -8 and square it and add it to both sides. Then you're going to rewrite it as the perfect square binomial, which is just the split of -8, which is -4. Notice that the square of -4 is 16. And now we're going to solve this. To undo this square, right here, we're going to take the square root. And we're going to get plus or minus 3. We're going to add 4 to both sides. And we're going to get 4 plus 3 and 4 minus 3. Those are our answers. Let's do a few more. Takes a while to get used to this. This time we have an odd number here, and this is going to make this a little messy. So just hang in there. Okay, we're going to isolate or move the constant over to the right-hand side. So this 5 right here moved over to the right by subtracting. We're now going to complete the square. We're going to write this as a perfect square trinomial. To do that, you split b in half. Split b in half and square it. So if I split this in half, I'm going to get 7 halves. If I square that, I'm going to get 49 fourths. And that's the number that goes in that box. This now factors to this. And this over here, if we make that -20, make that -20 a negative, or that -5 a -20 over 4. Combine those two together. Now we're ready to solve this quadratic equation. So to undo the square, we take the square root. The square and the square root cancel each other out. We're left with plus and minus 29 over 4, which can be split up into separate radicals. The square root of 4 is 2. All right, now we're going to add 7 halves to both sides. And that's your answer. Now you could write it underneath, or excuse me, over 1 single 2 as opposed to 2. It doesn't matter. Either way is correct. All right, let's take a look at another one. Isolate the 30, not isolate, move the constant over to the right. We're going to complete this square. We're going to make this into a perfect square trinomial by splitting b and squaring it. So when we're finished, we want x minus 5. This is the split of b. What's -5 squared? Because that's what's going to go in this box. Okay, so on the left-hand side, we're going to have -6. We're going to take the square root of both sides. And we know that anything with a negative underneath a radical is going to be converted to an I. We're going to add 5 to both sides. And this will be our final answer. Okay, let's look at it one more. This time, we're going to, again, pull that constant over to the right-hand side. And we need to divide by 3 this time. We need to get rid of that 3. This needs to be a 1. It has to be a 1 in order to complete the square. All right, and this is what we get. The number that we put in the box is half of b squared. So when we factor it, it's just half of 5/3. Half of 5/3 is 5/6. So the number that goes in the box is that number squared. Okay, this shows you how to get a common denominator. So if we need a common denominator of 36. We're going to multiply this negative 4 by 36 over 36. And that's what we get. We're going to take the square root of both sides. This produces an I. The square root of 36 is the same as 6. We're going to subtract negative 5, 6 from both sides, and our final answer is going to look like this. Now again, some of these look really messy, but you kind of got to get used to that. Math does get messy. So I know this video was a little bit longer than usual, but completing the square does take several steps. So hang in there and practice, practice, practice.